Yeah. Okay. All right. I am going to launch on in to my SVG work today. Got my coffee. Got an idea. Feeling pretty good. And yeah, that's all there is to it. I actually, I do want to try. I should have a new emote. Let's see how it actually looks. Oh. Am I not allowed to use my own emote? Huh. Well, okay then. Let's see here. Let's see what's going on. Huh. Looks like I can't use my own emotes. I have to. I want to search this for a sec. I want to figure that out. Let's see here. Twitch, use your own emotes. Let's see. Gotta figure that one out. Let's see here. Yeah, it is. Hmm. Hmm. I'm not sure things are working the way I want them to right now. Let's see here. Yeah. Well, okay, whatever. It isn't a big deal. Hmm. I thought this would all be super easy. I am just messing around here. I don't know what's happening, honestly. Just trying to... Okay, so if I do this... Okay, yeah, so Adam J2 Vibin. Yeah, that's weird. I don't know how to use my own emotes. That's the thing I'm confused about, but whatever. It's just gonna have to be fine. That's okay. I'm just gonna get to work instead. How about that? Let me do this. Hey, C Films, glad you're doing well. I'm doing well too. I'm trying to mess around. So I recently got affiliate, and I'm just looking through emotes and all that sort of stuff. So that briefly not doing my programming here, but that's what's going on here. Glad to hear you're well today. Let's see here. All right, that's good enough. Thought I was going camping this coming weekend. Yeah, I still am. I'm actually, after this stream, me and my roommate, we're gonna pack up, and tomorrow morning I'm driving out. So, yeah, so it's after the stream, basically, getting ready to go. How's the packing going? Yeah, haven't started yet. It shouldn't be too difficult, though. I mean, it's just a weekend camping thing. It's not like we need a ton of things. So basically just a tent and some food, that kind of thing. All right, let's see. You remember things about this stream? Yeah. That's cool. I appreciate that. Paying attention and all and whatnot. All right. So, last time I was using Clojure. Last time I was working on this distribute function, and I had this idea to work on this here, point driven distribution. And then, oh yeah, that's right, I have to get a regular polygon points thing, and then I'm going to start testing the distribution function. Distribution functions that I'm working on. So I have to find want to find regular, the word regular. There we go. This is what I'm looking for. This function, actually, I can pretty much copy it as is. I think that should be okay. Regular polygon points, it'll have a radius and a number of points. And that should work just fine. So let's try that out for def b regular polygon points. Let's give it a radius of 5 and a number of edges is 6, so it's a hexagon. And 1, 2, 3, 4, 5, 6 points looks good to me. I wonder, I think I'm gonna do utilities/round here and get things going that way. All right. Actually, let's do show SVG polygon B. Oh, I'm in a different namespace, so I have to do this SVG-CLJ dot tools/show, and that should open. Yes. Oh, that's weird. Why is it like that? Let's see. Oh, yeah. I did something wrong. That's why. See here, in the context of this, I copied this from a library that I'm working on for 3D modeling, but SVG is 2D stuff, so I only I should change this up. I should make it a little cleaner. Anyone have any cool weekend plans coming up? This is completely unrelated, but I got a Rubik's Cube recently, and I keep it on my desk, and I fiddle with it all the time. It's a distraction, but it is fun. It's very satisfying to use too, which is nice. Anyway, right. So what's going on here? I think that'll be fixed if I have to re-eval this, of course. There we go. Let's do def b. There we go. That's correct. Now what's well, actually, let me briefly have a look at this and see if I could clean this up just a bit. I think I can. Oh boy. So instead of a 4, I could do it as a map, and that might be just a little bit better. So let's just kind of do this. Map this function is going to be vec math cos. Oh, actually, let's do util/round It's the number and then the places to round. Yeah, so let's do round. I wonder if this is actually going to be more readable. We'll go with it for the time being though and see how it looks. So round the number to the 5 decimal places is good. And then we'll do the same on the next thing here, but first we got to do math cosine of the range times the angle Yes, that looks correct. Oop. And then this one is math/sine. Vec those together, and then you just map it over range n, like that. Let me do this just like that. Let's see if this will work. I think it should. Let's see here. Oop. Right. This should be into like that instead. Yeah. I bet there's even a cleaner way to do this. Wait a second. It's got to be like this, right? Why do I keep messing this one up? Oh. Let's try that. Oops. There we go. Oh, it's because of zoom level, I think. Okay, that's a good start. And now let's just do this cider show. Ooh, it's really tiny. Why is that? Oh, I messed something up. Angle times the step round maybe my round function doesn't actually work. That is very possible. Like what if it's small number why would the round, what am I missing here? Let's just get rid of the rounding just to confirm or disconfirm. Oh, yeah. Okay, so let's try this. Oh, I forgot to times R in there. That's all. That's what's going wrong. Well, let's get things back in shape here. Let's get the rounding back in there. We can keep that. Okay. And now I do need to, of course, multiply this whole thing by R. And to do that, I'll go here and multiply it by R here. So times R. That should fix that. Excuse me. Times R. Now let's give that a shot. That should fix it. So the numbers should be bigger. Yep. Right, so let's now do cider show the polygon. There it is. And now, right, let's swap this out for regular polygon points, a radius of 100, and we'll do 24. It looks kind of like a circle. That's exactly what I'm going for. Okay, so the reason I'm working on these point list generators is to use them in conjunction with point-based distribution functions. And all that means is you give a list of points and you give a list of items, or you give a single item and it will like copy and paste that item to each point is the whole idea. And then using those concepts, you can make a bunch of different layouts. So if you have a list of points that is a grid, then you could easily lay things out on a grid. If you have a polar array, which is exactly what this is, then you can array things around that around that section like a polar array, and on and on and on. So you can combine these two ideas pretty simply. I think this is a better approach than what I was trying to do yesterday. Thinking about it, I don't know that the distribute functions I was trying to build were that useful necessarily. I do have this one, which is the gap-based distribution. I still think that's going to be extremely helpful. So I'm just going with that for now. That I think that makes a lot of sense. So yeah, there's one, actually looking at this, I have one thought in my head here. Oop. Oop. There we go. No A, that's fine. Let's def A as repeat 3 SVG circle 20, and then let's now def B is just a SVG rectangle. Right, so A is a list and B is a single item. I forget what happens when I do group A, B. Okay, so it does turn this into a list, or it keeps it as a list inside there. Which should be fine, right? I think that should be okay. Show SVG-AB. Yeah, it works. This is a bad example. They're all just exactly overlaying each other, but that's fine. Doesn't matter. All right, that is fine. It's fine. It's fine. It's fine. I'm just trying to see if there's a way to make this look a little cleaner, you know? I think it should be okay though. I'm not going to worry too much about it. Okay. Let's. Why is this zoomed in, by the way? Inspect. No, it looks good. Oh, it's way zoomed in. Yeah, okay, there we go. That makes more sense. Okay, right. Next thing. Point-driven pattern. Let's use this in conjunction with the regular polygon points to make a test case. Let's now def A as SVG/rectangle 20 by 30, and we'll give it some color this time. Style, fill, pink, looking good. Now point-driven pattern. The item we'll pass in is A, and the list of points is regular polygon points. Radius 250, and we'll do 6 points. Okay, that's promising. I like the look of this so far. Def B. There. And now let's do. Yes, it's working. Okay, that is what I wanted to see. Happy with that. I'll be right back and go to the washroom. All right. So we do nicely have this working out for us. Let's change this, let's bring it in 150, and let's make this 25. So there you go. You see it's basically a polar array working for us nicely there. I'm happy with that. Now, I want to see this here, point-driven distribute, and what's a good way to test that out? Oh, I know. I'll make rand int. Let's define random rectangle. Come on, that's not what I meant to do. Ugh. Make a random rectangle is just going to be SVG/rectangle. Wait, we're also going to randomly color it, so let's do this. SVG/rectangle. Plus 5 rand int 20. Yeah. Oop. And then this is style. There we go. Fill is going to be string RGB. Oop. $255. $255 and close it off. That should work. Right? That should display just fine, right? Let's do tools, cider, show, random rectangle. Oop. Yep, that's working. Perfect. So let's do I forget how to do this. Repeat for. Hey, Chadwick, how's it going? I hope you're doing well today. I always forget how to run this. There we go. Are they actually all? No, see, this is what I always forget. It runs the random function one time and then just repeats it like that. Adam, what are we working on today? Today, I'm working on my SVG library In particular, I'm working on some layout functionality, and I'll show you what I mean by that really quick. So I've got stuff like, whoops, I recently switched back to a new keyboard, so I might be a little goofy on that from time to time. But so let's take this as an example. I have this rectangle here, A, and it looks like this. SVG-CLJ tools/show. Oop, A. So this is just a rectangle, right? Nothing crazy. B is a pattern of those, and I'm working on various combinations of patterning tools. So if I do here we've got A is the single rectangle and B is the pattern. So you can instance this around whatever. So this patterning tool works. I've got this function here, point-driven pattern. What you do is you pass in a single item and a list of points, and it'll copy that. It'll make new copies of that item you pass to each of the points. It's very simple. It's basically you just map the item over a translate to each point. This one is circular, but the whole idea is you can pass it any set of points. So if I do this, if I define a new point-driven pattern, and I want to give it the rectangle A and a list of arbitrary points. So let's do 0, 0, 20, 30, -10, 40. See that? It's displaying a little weird, but it's just being placed at whatever points I give it, right? So now I can if I make a bunch of functions that generate different types of point distributions, then I can lay things out however I want. So an obviously useful one is you've got the polar array, right? Like this. Clearly it's useful. You can just as easily do a hex grid pattern. You could do a square grid. You could have non-equal grids and all kinds of stuff like that. So quite useful. What I'm trying to do is check this. I have a slight variation on that function, which is point-driven distribute. And so the idea with the distribute function is, oh, you got to get going? Check in on you later. Cool stuff. Yeah, thanks. Oh, thanks for the follow too. I appreciate that. Have a good one, eh? Thanks for checking in. Where was I? I'm just going to verbalize this anyway. This point-driven distribute, it works the same way, but you give it a list of points and a list of unique items, and it'll, one at a time, it'll take a point off the list and an item off the list and move that item to that point, then move the next item to the next point, and on and on and on. So you could build nice distribution functions as well. So that's the idea today. That's what's up. That's what's up. All right. All right. So this random rectangle thing, I keep forgetting how to do this. If I iterate, that's not it. It's was messing around. I have to remember how to do this. Do seek maybe? Nope. If I just repeat this. Ugh, wait a second, can't I do for that'll work. That's good enough. Let's define B now to be for range 20 random rectangle. Oop. There we go. We've got 20 unique rectangles. Now I can test SVG-CLJ tools cider show point driven distribute B over regular polygon points 150. That's weird looking. I'm not sure that I did this correctly. Oh, okay. I see. That, so it pretty much works. Let's make this, oops, 20. Let's make it 25. There we go. Okay, so this is working the way I want it to. So I know the list of unique rectangles is 20. It contains a total of 20 rectangles, but the list of points that I pass in it contains 25 points. So what it'll do is sequentially, right, it'll move each item to each point until one of the lists is exhausted, right? If there's only 15 points, it does not loop around and put the rest of the items there. You need, yeah, this is exactly what I wanted. That makes perfect sense. So it doesn't like double things up onto points. It doesn't have any weird looking behavior like that. It's exactly right. So if I match point for point, it's exactly what I want. And yeah, that's looking pretty good. So let's keep adding a few pointless generators here. So let's define a grid now, right? That'll be good. And a grid needs X, Y, and X and Y. Let's start with that. And here, right, it's gonna be I forget how this works already. Let's just do this. For yes, I do want it to be a flat list. And so all it needs to do is generate points at like the total number of n points with the spacing between them. So for a range nx, b range ny, what I need to happen is create a point that is times xa times yb. Oop. And will that be sufficient? Oh, I goofed. I goofed it. There we go. Yeah, let's give that a shot. There we go. Right, we've got a grid. Let's do 10 and 10 and 5 and 5. Is that right? Let's see. Instead of this array pattern, right, we'll just do the grid. Actually, let's just do point-driven pattern, and we'll do SVG circle with a radius of 3. And then we'll do grid 10, 10, 10, 10. I mean, that looks pretty good to me. That's nice. I think that's good. Let's change the name of this to be, let's do width and height. Number of x, number of y, width and height. Let's do that. So yeah. I like that. I think that's perfectly good. Well, so that's this is a square. What's the name of this kind of grid? Let's see. Let's search this actually. Types of grids. Types of grids. Let's see what names there are for these things. So, I don't, go away. I don't want this. Please. The whole thing, please. Oh, jeez. All right, enough of this. I'll go somewhere else. I just need the names of these grid types. Organic, irregular grid, angled, circular. I mean, I guess it does make sense that you could come up with all kinds of grid classification. Let's see. Maybe good old Wikipedia has some helpful information here. Cartesian grid, non-orthogonal grids. I'm maybe getting a little too into the weeds here. Hybrid grid, yeah, this is all great. This is all meshing. That's a little beyond the scope of what I'm thinking of right now. I'm basically thinking like you've got your basic rectangular grid, maybe is what I should call it. Rect grid. Yeah, let's start with that. Then there's iso grid, right? An isometric grid. I don't want to learn how to use it. I want to learn how to generate it. Let's see here. This is not. I want the mathematics of an isometric grid. Amazing. There is a bit of math to it. How? Isometric grid points. Here, there we go. This is probably helpful. Isometric projection. Yeah, this is not necessarily what I want. Oh, maybe I can Okay, something like this is probably what I'm starting to think about. Probably what I want soon. Do wonder. Working demos are always nice, or usually nice. Hey Mike, how's it going? Long time no see, I hope you're doing well. I am in the middle of thinking about some of the grid generator functions I want to add into my library here. So I've got a rectangular grid thing already working. And I'm thinking about isometric grid stuff now. And while I think I'm fiddling around with this Rubik's Cube. Work's got you pretty strapped for time. You're doing well though? Glad to hear it. That's good. Work keeping you busy is probably tiring, but can be nice sometimes. So hopefully it's going well for you. How's life? My life is going well right now too. I have been going to a climbing gym a lot recently, which has been so much fun. I really like climbing. You really feel it in your forearms and your shoulders. So I'm feeling that today. Stream specific, Mike, I don't know if you've noticed, but there should be a subscribe button available now. I have done the whole affiliate thing, and I'm actually like a quote-unquote legitimate Twitch streamer now. So that was exciting. Thanks for the subscription. Oh man, that's fantastic. Mike, that's the second subscriber now. Man, Mike, thank you so much. Yeah, I'm super stoked. I am also very excited about it. While we're on the topic, can you do me a favor and just I see if you can use? I have two emote slots. You'll ban him or her? Well, can I can I request that you don't ban this person? Their name's John, and I actually live with the guy. He's a good friend of mine, IRL. So, he beat you to the punch just by proximity. No, I appreciate it, Mike. Although I do, it says you're first, so I don't know. Maybe something changed. Anyway, it doesn't matter. Oh, I see. There's different types of subscription. I get it. He subscribed with Prime. You subscribed with Prime. I don't know. I don't know specifically what's going on, but you've got a little first badge here, so. Yeah, there you go. All right, thanks. Emote works. I think I want to improve the emote designs a bit, but as a start, hey, John, how's it going? You have company now as a sub founder. So the emotes are working. I want to improve the design of them a little bit, but they're okay. Oh, you heard? Yeah, I talk too loud sometimes. I don't know why, but I currently cannot use my own emotes. Like I can't subscribe to my channel, so it's just not letting me use them, and I don't know what the deal is with that. But I digress. They do work, and as the design can be improved, the readability of them can improve, but they're not bad actually, and I created them myself, so that's pretty cool. All right, I'm stoked. Thanks, Mike. Thanks, John. Being the subs, it's fantastic. Right. So, nice. The emotes work. I'll take that as a win. It's a nice little win today. So, this rectangular grid, let's just double check this. It's working just fine. Oh, I closed the reference I needed, but whatever. I don't care. There we go. All right. Let's run the. I want to check. Now that I've got the pattern working, let's change this to distribute over a grid. But instead of this circle, I want it to be the list of rectangles. Ooh, why didn't it show? Oh, I was just impatient. I'm not sure that's correct. That looks weird. Oh, maybe the grid spacing isn't high enough. Let's try. 40. I'm not sure that this is correct. because this should be 100. Yeah. And if I count B, it should be 20. Keyboard sounds clackier. Did I start using a new one? Oh, yeah. So it's not actually new. I just haven't used it in a while. It's an Ergodox EZ, Ergodox EZ, as you might say. I don't know why I'm moving the keyboard. Let me try to. It's split keyboard goodness. I haven't used it in a while, so I'm a little rusty with it. I gotta practice. But yeah, that's that mechanical sound. Use it. You use one as well for your daily driver? Yeah, they're really nice. To be honest, the biggest reason why I didn't set it up earlier was because the USB cable was in a box in a corner of a closet that I just didn't. I kept forgetting to dig it out. Okay, so this doesn't look the way I expect it to. And the first thing here's what I'm going to try. I realize this might be related to the fact that I haven't wrapped that in an SVG container. Which I need to make. Okay, that's better. Yes, okay, so let's mess around with this. Let's change the grid numbering here to 5 by 5. Yeah, okay, that's looking good. Now, let's do 5 by 5 and change the spacing. Let's make Y only 10. It should squish it up this way. Yep. Things are looking good. Oh, Mike, have you been around to see this? I have a little function that I can display SVG directly in my REPL now. Hey, how's everybody doing, by the way? Anyone tuned in who hasn't been chatting at all, feel free to pop in, ask questions, say hi, all of that good stuff. I hope everyone's doing well. Let's change this to 300. There. Yeah, so I've got this cool little utility. Saw it at the start, haven't seen it in a while. Gotcha. Well, that bit's working okay now, and I use it a little more and more, actually. I'm realizing just how useful it actually is. It's very satisfying. It's really useful for these kinds of tests, too, where I'm like, I don't actually care so much about, like, I'm not working on the detail of a graphic, right? But it's quick to visually confirm, oh yeah, the spacing's working the way I want, this and that. It's really nice. And for anyone who might not be using, like theoretically there's someone using the SVG library that doesn't use Cider. So they might use Emacs, but they use inferior Clojure instead as their REPL or whatever. They can use show and it'll pop it in the browser nice and quick. Super easy. They're really small functions, but I might run with that idea and make a few more utilities that are a little more robust. But what I'm really happy with is like they work super well for being so simple as functions already. So that's really nice. Okay, so I have patterning, distribution, grid let's see here. I have one more idea. Well, one more. I've got how do I want to do this? I want to have a few tools for parametric curves that I can place points along the curve. So what I mean by that is something like here I've got a parametric line. Where is it? Oh yeah, it's this. I'm gonna change the name of it a little bit here, but let's do P line for now. It's not perfect, but we'll start with that. It returns a function that takes t. Yeah, and it does have cond. This is not good. But for extreme simplicity, let's do it anyway. As a start and hack on it from there. Oh, these have to be utils. Parametric line from 0, 0 to 200, 200 is a diagonal. So now if I do C0, I get 0. If I do C1, I get 200. If I do C0.5, I should get 100, 100. I do indeed. That's looking good so far. So what's the point of having a parametric curve function like that? It's to get, I could use that to make I don't know, points along is how I'm gonna call it for now. Curve and gap. Those are the two things you pass in. I probably want to redesign the argument structure of a bunch of these functions, but getting them in here as a start is not a bad idea, I think. Right, so curve is, for right now, I'm just using this parametric line function. It's going to return a function of t. But you could imagine any curve, right? It doesn't have to be a straight line. It can be a Bezier curve or whatever. And you just parameterize it with t. And then, as long as t is from 0 to 1, this points along function will work. It should work. Although, let me think about... There is one trick here. I'm gonna change tack to do the slightly easier thing first. And that slightly easier thing is let n be count. Oh no. This is, so I'm gonna have, sorry, I'm gonna back myself up a little bit here. Points along a curve is something I want to do, but it's actually going to be a little bit harder than what I was just thinking about. What's actually going to be easier is a distribute along function. So, oh, this is also just a test function, so that's going to get deleted at some point. That's fine though. So here I'm going to define distribute curve. Let's do curve driven. These names aren't great. Distribute on points. Distribute linear. I don't necessarily love these. Pattern on points, but I'll start with that. The names can come later as I get closer to what I want. Distribute on curve. Right, so items, n items and one curve. So let n be count items. Yeah. And then the step size is 1 over n. I think that makes sense. Then all you have to do is map the function thread first the item over translate to the position curve along the step position of the curve there. I'm saying words, but I don't feel like they're actually making sense to any viewers. But that's gonna be okay. I'll explain this in a minute once I'm confident it works. Items, range, step. Nope, that's wrong. Range 0 to 1.0 step. I think this will work. Right, so let's do what's an easy way to kind of confirm that this works? Tools cider show. Let's change our tactic again. Let's try thread first, this whole shindig. We're gonna just do circles, classic thing to test. We're gonna run that through repeat. Take. This isn't gonna work the way I want it to. Let's back this up just a minute. We'll wrap the whole thing. Let's do 400, 400 is the SVG size. We're going to just do we're going to distribute on curve the repeat 50. Oh, no. Let's back that up. Let's do B as a list of 20 random rectangles. And the curve we want to distribute it along is the the parametric line from 0, 0 to 400, 400. So it's the diagonal across the whole drawing. Look at that. That worked. That worked like a dream. Man, that's cool. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Boom. That is cool. I am pleased with that so far anyway. Let's change up how we do this, right? So we'll make the start point easiest first try ever. Feels good, man. Feels good. Let's move the points a little bit to just double check that it is kind of working the way I want it to. So it implicitly it'll evenly distribute the points along the curve. So if I shrink the curve up, you should see all of the rectangles get scrunched closer and closer. I'm also going to change the angle of the lines so that let's put it into the middle of the canvas. So the start points Y position I'll make 200 and the end points I'll also make 200. But I also want to just move it in 50 on either side. So it should be 50 and 350 here, and it should be now a straight line squished a little bit. And that's exactly what we see. So things are, everything's coming up Millhouse. Now let's just quickly, oh, I haven't defined that function. I don't need that. Let's now do the same thing. So we've got distribute on curve and pattern on curve. I want to put a little note here. Pattern and distribute are so similar. I wonder if I should remove one of them, as in have distribute work, no, have pattern work on either a single item or a list of items. I'll cross that bridge when I get to it. Let's define pattern on curve here. The nice thing is it's easier. The only thing I need, oh, wait a minute. Pattern on curve might be, so I need the item, but I actually need the user to specify no, I was saying this is actually a little more complicated depending on how I want, like on what I want the user to be able to drive. Like, do I want the user to say pattern as many along the curve that will fit given a spacing of whatever, or fit n items onto this curve? Both can be useful, so I kind of want both to be available. We'll start with the one that's definitely easier. I'll do item, curve, and n is the number of items that I want patterned. So I basically just have to do this. And in fact, here I can change the mapping to just be like this. Item. And that should work just fine. So let's do this now. Pattern on curve. Oop. Oh yeah, of course, I forgot already. I need to do this. There you go, that works. Okay. That's working nicely. I will be right back and get myself some coffee. There we go. Okay, so we've got distribute on curve. The reason doing the distribution the other way, where you specify the gap that you want, is the reason that's harder is because you're kind of converting from screen coordinate space to parameter space. So what I mean by that is let's make a line, parametric line from 0, 0 to 100, 100. Okay, nice and easy. ASDF 0.2 is 20. That makes sense. So what you need to do, util/distance, right? You need to know the change in parameter for the change in distance, and that also only works for straight lines. ASDF, so let's say the distance between ASDF 0 and ASDF 1 is obviously going to be 100, 100. It's going to be 100 times root 2, I think, right? So 141 or something like that. Yeah. Called that shot. But if that curve were the equation for a circle, the distance from from the start and end of the parameter of the parametric would be 0. It'd be a distance of 0, right? So that's not helpful. And you get 0.5, and the total distance would be the maximum. It would be the diameter of the circle. But that's not the metric I actually want. I want the distance along, like traveled along a curve. I don't know how to solve this one yet. I have to think about that a little bit more. Pattern on curve. Let's, instead of worrying about that for right now, let's have a peek at what other curve functions I can use. Because I think I've got more than one. So I've got a circle function. I have an ellipse. Do I have an ellipse parameter? Yep. Arc. I have, let's see. It's a bit tricky to solve for sure. First thought would be keep a running total going. Like you said, if it's a circle with start and end point only, you're in trouble. Yeah, the other thing I'm trying to think about is what the use case of this is. Like, I don't want to. I'm trying to think. If I'm trying to pattern a thing along a curve, am I more likely to want to control exactly how many instances go along the curve, or will I want to control exactly the distance? And if I'm creating the curve that I pattern it along anyway, is that plus controlling the number of instances, shouldn't that be enough? I don't know the answer to those questions, but that's also going through my head here. So I want to have a solution that's going to be reliable, that isn't too bug and error prone, and is still useful to the user, right? I also forget there is a, is it called arc distance? I think that, oh, I didn't mean to do that. I think it's called arc distance, arc length. No, that's only true for an arc. Distance along a curve. Right, so what if s equals s of t where s is not constant, right? Then you have to integrate over the time interval. Yeah, I kind of feel like implementing integrals into the layout functions are maybe a little bit overkill at the moment. Maybe it's not too hard, but this is something I'm gonna have to think about what I actually need to do properly, right? But this actually makes sense, right? If you think about it, you got your distance integral from a to b. Yeah, for dx dt squared. Yeah. This is basically Pythagoras, right? If I wanted reliable derivatives as well, I'd have to start learning, and I don't know this yet. I don't know how to do this yet. Automatic forward differentiation. These are techniques a little bit beyond my understanding at the moment. Those are problems for another day. How about that? Let's do let's try the curve arc, or the arc curve function, and see if that reveals anything useful. We've got, what do we got? What do we have? Center from points. Time for a good old calc lesson. Get the old TI calculator dusted off. Yeah, seriously, right? Yeah, that's gonna be an off-stream activity. At least initially. Once I feel confident in explaining things again, then I can make videos and stuff about it. But yeah, I'm not confident enough at the moment to right away bang out explanations here. So that'll be for later. Right. So here we've got the curve, but there's a few functions here. Oh, I need to do a few things to get this working. Let's start with the parametric circle then. Oh boy, is this actually what I want to be doing? I'm starting to second guess my decision here. Oh no, let's go with it. Let's try something. Let's try it. I don't remember. See, there's a bunch now. The only trouble is there's a bunch of utility functions I have to start pulling in as well, and I feel a little less comfortable starting to load this library full of math like that. Although, I mean, this isn't a big deal. Why am I making a big deal out of this? It's not too hard to do, so let's do it. These ones here, radius from points and center from points, I think should just be private functions in here. Like this. Whereas in this Forge prototype, they are where? Man, I really gotta dust this one off, this Forge library. Got work to do. That's the model. Here, I think I've ordered this wrong actually, but it's neither here nor there right now. So here we go. A few of these already made it into this library anyway. Clamp is probably useful. But let's not add things until we need them. List manips, geometry stuff. Here we go. So we have normalize, and normal should be somewhere here, right? Am I thinking about this correctly? Center from points. This is going to be different than the centroid center thing. That's not going to be the same. Cross product, right? So I'm getting into 3D territory here, technically. This, by the way, can just be let's add it all in, but before I do, actually, let me do this. So we're at a point here. Oops, that's not what I meant to do. Let's commit this stuff to Git while we've got a working set of things. Oops. So git branch parametric on branch main. Oh, git checkout para git status. Oh, git branch. What branch am I on now? The parametric branch. Okay, that's good. I realize you might not have been able to see all of that because it's behind my camera, but it's nothing that crazy anyway. Just trying to merge some changes and push it to origin and all that stuff. So this should say on refresh a few seconds ago, 1 minute ago. Yep. Oops. All right, let's start hacking this up. All right, let's add a few utility functions. We've already got angle from points. We've got a dot product in here already. So we're most of the way there with a lot of this, so it's not that big a deal. Okay. Let's put cross product right here. So A and B, they have to be 3D vectors, which is fine, but it means I have to add Z automatically. I don't know where it would be appropriate to do that. I don't think it would be appropriate to do it in the cross product function because that isn't really valid necessarily. Seeing git commands is overrated. Seen it once, you've seen it 1,000 times. Yeah, they're pretty straightforward once you've used git yourself, right? Yeah, so that should be okay. Normalize is easy. Find the unit vector of a given vector. Normal vector of a plane. Since I'm in 2D, the normal vector is guaranteed to be 0, 0, 1. So technically I don't really need this, but I'm going to put it here for the time being. And then this radius from points is what I need to have as well. And this is going to go in the layout. Here, parametric curves. There. And this one as well. See, there's a big part of me that thinks I should actually not include this kind of stuff in the library. I feel like this is really touching on the edge of the scope of this SVG library, but layout stuff is important, right? So I'm flip-flopping in my head as to whether or not this is a good idea. But I'm not on the main branch, so it's okay. Estimators. Yeah. For now, okay, I think I've collected all the right functions. Now let's work on building it into a working situation. And we'll do that by first saving this here. I think it's okay to include these are not utility functions to be used across different libraries you're developing, right? That's the thing. Theoretically, no. But for example, so this SVG thing is strictly 2D drawing for SVG purposes, right? Like, well, you can use the SVG library to make 3D isometric things. I have, but the library itself doesn't assume that you're necessarily working in a 3D context. So the functions that are, say, normalize and normal, for example, technically can be used in the 2D context, but also in my 3D CAD stuff. So they're potentially applicable, but not necessarily applicable. You know what I mean? It's like really kind of borderline. I think they're small enough that it's not that big of a concern yet. I can always rearrange later too, so I don't think I should worry too much about it. And it's always easy to delete code, right? Well, that's not strictly true, but I always like deleting code, so so I can work with that bailout option. So let's load file, hopefully SVG-CLJ utils.cvc. Online. That's gotta be right here. That online predicate gets dangerous because I'm pretty sure it requires floating point checks. Yep. Nearly. I don't like it. I mean, if I get rid of the check, let's get rid of it for now. Maybe I regret that, but oop. Yeah, I don't know. I'm trying to think if the only context where this, and I could make these private functions and only use them in a context where I can guarantee that it won't pass in linear, like 3 points on a line. I could maybe set it up to guarantee that, and then I don't have to do any checking. The reason I don't want to do this is I want to force as little checking between float values as possible in the SVG library, because that is just fraught with peril. And two, if I have to do it, I don't necessarily want I don't know, it's an extra dependency that I might not want to have because of compatibility with Java or Clojure script. But I'm getting ahead of myself and worrying about it too much. So we'll just go with we'll roll with this and see if it works okay. Oh, did I not save this? There we go. Now let's pop back into layout and get the ball rolling on this one. All right, what are we missing? Yes, yes. Right here, of course. Let's make these private, like I said. We've got online here and online here. I'll use the same logic and assume that I can pass it in safely. Again, I might regret it, but you know what? You live once. Likewise here. Oop. I realize I've been getting lazy again with learning Paredit, and that's shameful of me. This here, I can do utils / v minus. Yep. Utils. Just making my eyes go screwy. Utilities / why don't I use this handy thing called copy paste? You ever heard of that? It's this amazing new feature. And SQ is square, of course. How did I implement that up here? I know it's... Wait, isn't there math / square? Oh, it's POW, right? And POW is something like if I do 5, 2, that should be 25. Yeah. So I could change this to math POW 2. Yes? I don't know if that's better. This is really confusing. maybe that'll work. This is atypical, so let's do this. Let's call it radius and return radius. 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 There we go. I need to take a break. Normalize doesn't exist. What are you talking about? Normalize doesn't exist. Of course it does. Where is that? What? There it is. So if this compiles, pow taking 1 args, did something wrong. Can't find it if it doesn't exist. I goofed somewhere. All right, let's, this works. Let's check this one, that's fine. Okay, utils, this is all good. Up to here for sure, it's fine. Here, I might have messed something up. Math, pow, this, here, this is where something went wrong. I forgot to add 2 here. Ooh, so close. Okay, there we go. So that now, all the symbols are there, but there's one thing that will still break this. These points are assumed to be 3-dimensional when I pass it in there, I think. Or they have to be because of this line here. I need the cross product. It won't work with only 2-dimensional things, right? It is actually undefined for 2D shapes. That is true, right? I think it's true. I also realize, I just realized this. I could... I'm not going to worry about that. I was going to say this here, V, could just be replaced, I'm pretty sure, with 001 right away. And then this W1 could be -1 or something like that. But I'm just going to leave it be, get things working, and then see if it'll actually work the way I need it to. Okay. So using those things, I should now finally be able to get in here and add from this circle this whole business. Let's copy this, see if we can get it in there. We'll call this Parametric Circle. Once again, let's do this. ABC is going to be map concat that'll work, right? If I do concat and the first thing is a vector of 2, it's 2-dimensional, and then I want to add z to it, 1 2 0, that should work. But I do want to do conj would work too, right? Collection. There we go, that's a better way to do it. Conj, the vector, and then 0 on the end, and it stays as a vector, and the points passed in are vectors, so that should all be good. Then all of this should work, as long as I use the right namespaces. This is like that. Utilities cross product. Yep. Let's get rid of this. No. I'm not sure that I'll leave it in. I'm not sure that that's smart, but we'll go with it for now. Vec drop last A. It's also true if t is 1 because it's a circle, right? So it'll start and end at exactly the same point, so you could just pass it directly. But since I added a z value to A, I need to return it as a 2D thing again because this is a 2D context. And then here, utils v star or v plus. Oh, likewise, utils slash here and utils slash this. And then this whole thing is vec of drop last. And if this all works, I can clean it up. Will it all work? That's the question. I kind of think not. I feel like I missed something. But let's give it a try anyway. Parametric circle, and I want it to be from, gotta have faith in the code, man. Well, yeah. And I mean, if it doesn't work, I can always poke around and learn to make it work again, right? Like, it's totally fine. The 3 points that I want to define this circle. Excuse me. 2020. 40, 0. 45, 60. So at the exact extents, it makes sense. Those are points. Seems to be working so far. Map v util slash round 5. Let's try again. Promising. Okay, so now, where was I? What was I doing? Let's pop back and try to find we've got this pattern on curve, a circle. Let's pattern it around the curve instead of this P line here. Let's do it along ASDF, which is that circle. Ooh, that's I messed it up. Pattern on curve. This thing, this curve, this many times. The whole SVG thing. Why is it threaded? I don't need to thread it, right? Uh-oh. Ugh, I'll rewrite it. Tools. Cider, show, SVG/SVG. Pattern on curve. The shape, SVG/circle with a radius of 5. We'll pattern it on the curve ASDF. We'll do 5 instances. We'll do 300, 300. Hey, wow. Wow. It actually worked. Mind blown. It worked. That's cool. Okay, now let's keep going. Whew. I honestly I'm shocked that worked. Told you so. Trust the code and wing it. Every time you deploy into production, right? Crack your fingers, trust the code and wing it. No, I'm kidding, but you were right. You were right. I didn't trust myself. Oh no. What have I done? There we go. Okay, so that worked quite well. So the interesting thing about this, right, is this is a little more complicated precisely because the way the circle is defined is passing in 3 points. So any circle can be uniquely defined by 3 non-linear points. So if you imagine a triangle, you can always circumscribe the triangle. You could always draw a circle around the triangle hitting the 3 points, no matter what. But you cannot do that with a straight line. If any one of the 3 points is off of the line, then you're good to go. It could be a huge circle if they're very close, but if they're exact, it won't work. Anyway, that's what all this extra math is for, really. And then this is just checks for the bounds of your parameter. But you could actually define it way easier if you pass in just a radius, which is very similar to the regular polygon points generator. Here, it's basically doing 2 things at once. It's automatically doing. Sorry, 1 second. Yeah, this regular polygon points function is doing the parametric circle and the discretization of the parameters in one step. You could actually separate this out into the parametric circle function that literally just takes the radius and then use that inside whatever function here and discretize it yourself. So you that can be separated out. In fact, I should probably have that as an option. Let me just make sure that my brain's working. Let's do this. Parametric Circle 2, temporarily called that. Bad name, right? So I don't need the angle at all. I basically, it's going to just be this. But instead of Rx, Ry, it's just one R value. That's the whole thing. So I can, actually, let me do that. Oop. Function of t. Yeah, that's it. Boom, done, easy. Print it. Broke it. Where'd I go wrong? Oh yeah. There. Right, so using that exact same logic, right? This, instead of ASDF here, I can do P circle 2 and give it a radius of 50, and it will do the same thing. It's just centered around 0, 0 instead. So what would be smarter, or what might be smarter, is a multi-arity function like this, where I can, so instead of this, I could do, if you pass it just the radius, you get this function. And if you pass it 3 points, you get this whole mess, and then it is the same idea. I think that's smart, at least for now. Seems reasonable. And that should, whoops, should cover the bases. And then if I get rid of this, oh, gotta fix it. Did something went wrong? There we go. All right, save this. Be right back. think I'm gonna go soon, but while I'm here, I should also, well, I can add a few more of these things, right? I can add the ellipse almost for free, super easy anyway, and parametric ellipse like this. Yep, that works. Nice. I'm super happy with that. That's really great. And now let's do circle, ellipse. Let's get that arc in there. Ooh, do I? Okay, I've got this. Parametric arc. Parametric circle. Utils slash center from points. I think this works. Oh, did I not? Oh, no, this is not their private functions here. Yes. Oop. That's gonna be here. Angle from points is somewhere in here. I don't remember if this actually works perfectly yet or not. But we'll go with it for now. Get rid of that. Oh, right here. Okay, the arc, I do think the arc will struggle a little bit. I'm not sure the arc is going to be perfect yet, but let's see. Let's see. Null pointer exception. There you go. Why is that? Let's just def these points 20, 20, 40, 0, 45, 60. Right, so center from points. Oh, I have to apply that. apply center from points to the list points. I'm a little confused because, oh, wait a second, it's right here. It's because of this. I need to do this on the arc points like this, and now it should work a little bit better anyway, potentially. Yep. Let's hope this works. Looks like it does. It looks like it does. Okay, that's pretty promising. Yeah, let's have a quick peek then at, well, let's save this actually. And let's see if there's any other, I can't remember, I had started messing around with parametric spline functions, but I don't remember if I got that working, / if it was a good idea. I don't remember. Let's keep reading through some of this though. So we've got the model, 2D rectangle. Oh, this is not quite what I was thinking. Sorry, actually. Sphere, yeah, that's all for later. Let's go peek a little bit more at these yet. So the SVG stuff, I'm only focusing on 2D, so I've got line, circle, ellipse, and arc already. I don't think fillets makes any sense, to be honest. That seems unnecessary. Triangle. Surface triangle. The F rep is also different. Yeah, that makes sense. I think that's all I've done. And the spline stuff I don't think is functional yet. Try again with Pomax tutorials. Yeah, I never got it working perfectly yet. So that's gonna be a deep dive another day for sure. And that's only because doing Bezier curves and all that stuff, there's good tutorials. I just have to rework this code. I think I have to rework this code. Yeah, I don't remember what I was doing with this. So, I'll have a look at that another day. But let's focus back in on there is something that is not considered in the layout functions yet. So let's oh boy, there's a lot of stuff now all of a sudden. Let's look at layout here. So pointless generators, I've got a rectangular grid and a polygon points function. That's pretty good for now. Absolutely there are other grids worth making, but for the time being the rectangular grid's okay. Parametric curves, I've got a line, I've got a circle, an ellipse and an arc, and that's pretty good as a start as well. I'm okay with it for now. I wonder if I should no, I'm not going to worry about that. I'm going to leave that. Yeah, I'm going to call that okay for the time being as well. I was wondering if I should make an equivalent. So arc is like a percentage of a full circle. I'm wondering if I should do like an elliptic arc function that works the same way. But I actually think that would start to get complicated again. So I'm not going to do that. Yeah, no. I'm going to leave that alone. So that's fine. But the thing is, if I, for example, do distribute on curve the list of 20 random circle, or here, it distributes them along that curve, but it does not rotate them. So it might be desirable to rotate a shape so that its normal is perpendicular to the tangent of a curve at the particular point that it's at. So that's another feature that would be good, I think. So let's have a thought about that for a moment. Let's think about it. So what I need to do is, for any given curve, I would need a way to calculate the tangent at any given point. So tangents and parametric equations, yes, yes, yes. Surely this is going to be a little more complicated than I have time to do today. But that is another consideration to make. You need the derivatives. Yeah. Okay, that's going to be a good place, I think, to call it for the day. I'm still, I gotta say it, I'm quite pleased with the progress I made today. Changed my approach from what I was trying to do yesterday. Got some nice, good functionality out of this. Like, even if I leave it alone and use it as is, it's already looking pretty good. So feeling confident about that. Before I do get going, I will make a little quick point. If there's anyone new who's tuned in and isn't aware, I just put in the chat there, I've got a link to a YouTube channel that I work on. It has Clojure video content on there as well, going into explanations about certain functions and whatnot. And as I keep working on this Twitch channel, I also am working on that YouTube channel. So give it a look if you want, and consider that. Am I going to be streaming on Wednesdays regularly now? I don't know. Probably not. The reason I am streaming this Wednesday is actually because I'm going camping tomorrow and Friday. So I wanted to, since I'm recently affiliate, I wanted to I wanted to get a little bit of stream time going. So I was making up for the fact that I'm off for the next 2 days by streaming today. But actually, I do have a question. Do you enjoy, like, I could rework my schedule. Are Wednesdays a potentially good day? That's a question I have. I don't know the answer, but there's no strict reason not to. It's just to balance my own mental well-being, you know. Good either way. Just curious. Okay. Yeah, so to give a straightforward answer, nothing really is changing at the moment. Typically, I assume Monday, Tuesday, Thursday, Friday, and I'll do my best to update things as they change. The reason for this week is just because I'm gone Thursday, Friday, and I wanted to stream a bit as an affiliate because it's still a big deal for me. But that's all I got to say. Just want to say thanks to everyone tuned in. Thanks for Mike today for your Prime sub. I appreciate that a lot. That's really cool. I'm super excited about that in general, and that you're able to support the channel in that way is just fantastic. I'm so happy with that. And yeah, had great progress today. Just a good day all around. All right, that's going to be it for me though. Bye everyone, and I will see you next week. Have a good long weekend too. If you're able to celebrate in any way, have fun. All right. Bye.